Hello everyone and welcome. In this video, we're going to explore the slant height of a cone, a fundamental concept in geometry that you'll encounter in many mathematical applications. The slant height is the distance from the tip, which we call the apex, of the cone down to any point on the edge of its circular base. This measurement is crucial when dealing with cones, especially when calculating surface area or solving related geometric problems. We will learn how to calculate the slant height using the Pythagorean theorem, connecting this geometric concept to fundamental mathematical principles you already know. In the next section, we'll dive deeper into the geometry of cones and see exactly how the slant height, and radius work together. Now that we understand what slant height means, we need to examine the geometric relationship between the three key measurements of any cone. Every cone has three fundamental measurements. First, we have the radius, which is the distance from the center of the base to its edge. Second, we have the height of the cone, which is the perpendicular distance from the apex straight down to the center of the base. Third, we have the slant height, which is the distance along the curved surface from the apex to any point on the edge of the base. Here's the key insight. These three measurements, the radius, height, and slant height, form a right triangle inside the cone. Notice that the height and radius meet at a perfect right angle. That's a 90-degree angle. This makes our triangle a right triangle. In this right triangle, the slant height is the hypotenuse, the longest side that's opposite the right angle. The height and radius are the two legs of the triangle. This geometric relationship is fundamental to understanding slant height. Because we have a right triangle, we can use the Pythagorean theorem to find any missing side when we know the other two. Whether you're looking at a traffic cone, an ice cream cone, or a geometric cone in a math problem, this right triangle relationship always holds true. The slant height will always be the hypotenuse of the right triangle formed by the height and radius. Now that we understand the basic geometry of a cone, we can derive the formula for calculating slant height. The key insight is that the slant height, radius, and height of a cone form a right triangle. This formula comes directly from the Pythagorean theorem. To understand why, we need to visualize how these three measurements relate to each other in a cone. First, let's identify the radius. The radius is the distance from the center of the base to the edge of the base circle. Next, we have the height of the cone. This is the perpendicular distance from the apex straight down to the center of the base. Finally, the slant height is the distance from the apex to any point on the rim of the base. Notice how I'm drawing this as a dashed line to distinguish it from the cone's edge. Now comes the crucial insight. These three lines, the radius, height, and slant height, form a right triangle. The right angle is formed where the height meets the radius at the center of the base. Since we have a right triangle, we can apply the Pythagorean theorem. Remember, the Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals the sum of squares of the other two sides. In our triangle, the slant height L is the hypotenuse, while R and H are the two legs of the right triangle. So we can substitute these values into the Pythagorean theorem. To solve for L, we need to take the square root of both sides. This gives us our slant height formula. Let's break down what each part of this formula means. The R represents the radius of the cone's base. This is always measured from the center to the edge. The H represents the height of the cone, the perpendicular distance from the apex to the base. We square both R and H because that's what the Pythagorean theorem requires. Finally, we add these squared values together and take the square root to find L, our slant height. This formula will work for any cone, regardless of its size, as long as you know the radius and height. Now that we understand the formula, let's break down the calculation process into clear, manageable steps. This systematic approach will help you calculate the slant height of any cone accurately. Step 1. Identify and measure the values you need. You must know the radius of the circular base and the height of the cone. The radius is the distance from the center of the base to its edge, while the height is the perpendicular distance from the apex to the base. Step 2. Square both the radius and the height. This means multiply each value by itself. We calculate r squared and h squared. This step is crucial because it prepares us to use the Pythagorean theorem. Step 3. Add the squared values together. take r squared plus h squared. This gives us the square of the slant height. This addition combines the horizontal and vertical components of our right triangle. Step 4. Take the square root of the sum. This final step gives us the slant height. The square root operation reverses the squaring we did earlier, giving us the actual length of the slant height line. Let's see the complete process in action. We start with our cone, identify the radius and height, square both values, add them together, and take the square root. This systematic approach ensures accuracy and helps you understand why each step is necessary. Remember, this process works for any cone, regardless of size. The key is following each step carefully and understanding that we're using the Pythagorean theorem to find the hypotenuse of a right triangle formed by the radius and slant height. Now that we understand the slant height formula, let's work through our first example problem step by step. We have a cone with a radius of 3 units and a height of 6 units. We need to find the slant height. Here's our cone. The radius extends from the center of the base to the edge, and the height goes straight up from the center to the apex. The slant height is the distance from the apex to any point on the rim of the base, shown here as the dashed orange line. Now let's solve this step by step using our slant height formula. Step 1, we apply the slant height formula. The slant height L equals the square root of r squared plus h squared. Step 2, we substitute our given values. R equals 3, so r squared becomes 3 squared. H equals 6, so h squared becomes 6 squared. Now let's calculate the squares. Step 3, we calculate each square. 3 squared equals 9, and 6 squared equals 36. So our formula becomes L equals the square root of 9 plus 36. Next, we add the numbers inside the square root. Step 4, we add the numbers inside the square root. 9 plus 36 equals 45, so we have L equals the square root of 45. Finally, we calculate the square root to get our answer. Step 5, we calculate the square root of 45. The square root of 45 is approximately 6.71. Therefore, the slant height is approximately 6.71 units. Remember, it's crucial to always include units in your final answer. Our slant height is 6.71 units, not just 6.71. This completes our first example. We successfully used the Pythagorean theorem to find that a cone with radius 3 and height 6 has a slant height of approximately 6.71 units. Now for our second example problem. We have a cone with a radius of 5 units and a height of 12 units. We need to find the slant height. First, let me draw our cone with the given dimensions. The radius is 5 units and the height is 12 units. We need to find the slant height, which I'll show as a dashed orange line. Notice that the radius, height, and slant height form a right triangle. This is why we can use the Pythagorean theorem to find the slant height. Now let's apply our slant height formula. We substitute our known values. Radius equals 5 and height equals 12. Step 1, we substitute r equals 5 and h equals 12 into our formula. Step 2, we calculate each square. 5 squared equals 25 and 12 squared equals 144. Step 3, we add 25 plus 44, which equals 169. Step 4, we take the square root of 169. Notice that 169 is a perfect square, so the square root of 169 equals exactly 13. This is a special example because we got a whole number answer. The numbers 5, 12, and 13 form what's called a Pythagorean triple. This means that some cone dimensions will give you perfect whole number slant heights, while others will give you decimal approximations. Therefore, the slant height of this cone is exactly 13 units. This clean whole number result makes this a particularly elegant example of the slant height formula in action. Sometimes in cone problems, you won't have the height given directly. Instead, you might have other measurements like the volume or the slant height. In these situations, we can use alternative formulas to find the height we need. In our first scenario, imagine you're given the volume of a cone and its radius, but you need to find the height. This commonly happens in real-world applications where you can measure the volume of a container, but need to determine its dimensions. We start with the volume formula for a cone, V equals 1/3 pi r squared h. To solve for height, we need to isolate h on one side of the equation. Multiplying both sides by 3 and dividing by pi r squared, we get our first alternative formula. H equals 3v divided by pi r squared. This formula allows us to find the height when we know the volume and radius. Now let's look at our second scenario, which is actually more common in geometry problems. In our second scenario, you know the slant height and the radius of the cone, but you need to find the vertical height. This situation often occurs when you can easily measure the slant distance but need the perpendicular height. The key insight here is that the height, radius, and slant height of a cone form a right triangle. The height and radius are the two legs of the triangle, while the slant height is the hypotenuse. Since we have a right triangle, we can apply the Pythagorean theorem. The slant height squared equals height squared plus radius squared. To solve for height, we subtract r squared from both sides, giving us h squared equals l squared minus r squared. Taking the square root of both sides, we get our second alternative formula. H equals the square root of l squared minus r squared. This is our most commonly used alternative formula. Let me summarize both alternative formulas and when to use each one. Here are both alternative formulas for finding the height of a cone. Use the first formula when you know the volume and radius. This formula comes from rearranging the volume equation for a cone. Use the second formula when you know the slant height and radius. This formula comes from the Pythagorean theorem applied to the right triangle formed by the cone's dimensions. The key is to identify which measurements you have in your problem. Then choose the appropriate formula. Both formulas are equally valid and useful, depending on the given information. In the next section, we'll see these formulas applied in practice. Now that we've explored the slant height of a cone through multiple examples, it's time to recap the essential concepts you've learned today. Remember, the slant height of a cone is the distance from the apex to any point on the rim of the circular base. This measurement, along with the height and radius, forms a right triangle. The fundamental formula for calculating slant height is L equals the square root of r squared plus h squared. This comes directly from applying the Pythagorean theorem to the right triangle formed by these three measurements. There are three key takeaways from today's lesson. First, the slant height always forms a right triangle with the height and radius of the cone. Second, you can always use the Pythagorean theorem to find the slant height when you know the other two measurements. And third, understanding slant height is essential for many cone-related calculations, including surface area and volume problems you'll encounter in geometry. Visualizing this right triangle relationship is crucial for understanding not just slant height, but many other geometric concepts as well. I hope this comprehensive exploration of slant height has given you the confidence to tackle cone problems in your geometry studies. If you found this tutorial helpful, please give it a like, leave a comment with any questions you might have, and don't forget to subscribe for more mathematics tutorials. Keep practicing with different cone problems, and remember that mathematics is all about understanding the relationships between different measurements. Thank you for watching, and I'll see you in the next tutorial.